Okay guys, today we're going to go over conditional statements. You need to know that there will be a lot of writing. It's all manipulation of sentences, specifically if-then sentences. So conditional statements are a statement that can be written in if-then form. The symbolic way of seeing that is a P and then an arrow to the right and then Q. And it's read as if P, then Q, or P implies Q. Although almost all the time you will hear it said as if P, then Q. The hypothesis is the phrase immediately following the word if. It's also the P part. The conclusion is the phrase immediately following the word then, and it's also the Q part. So in this situation, it gives you an if-then sentence, and it says, if you live in Nashville. That is the hypothesis, the you live in Nashville. It does not include the if. A hypothesis will never use that word if. It's just that part after if and before then. So my hypothesis is you live in Nashville. And then your conclusion is whatever comes after the then. It does not include the then. It's just the stuff that comes after then. So the conclusion is you live in Tennessee. So for number 2, whatever comes after the if and before the then is your hypothesis, and what comes after the then is your conclusion. It does not include the if or the then. So go ahead and pause the video and write it now. So if you did it correctly, it should look like this. The hypothesis is the sum of the measures of the two angles is 90 degrees, and the conclusion is they are complementary angles. Go ahead and pause and see if you can do number 3 on your own. If you did it correctly, it should look like this. The hypothesis is a quadrilateral is a square, and the conclusion is it has 4 right angles. All right, so here comes the harder part. We have to write these in if-then form. Normally, whenever you do this, it always helps if you ask what comes first. So what should happen first? That is always your hypothesis, and then what comes second is your conclusion. So in this first sentence, it says an obtuse angle has a measure greater than 90 degrees. Now this is an actual definition, so it can actually go both ways. So you could put the hypothesis as the conclusion and the conclusion is the hypothesis, and you would still get it right. But whenever it's already written in a specific order, you normally will write it in that same order when it's a definition, because an obtuse angle doesn't necessarily come before a measure greater than 90. You could have a measure greater than 90 and then identify it as an obtuse angle. There's no coming before or after. So whenever that happens, you can write it in either order, but it is more proper to write it in the order it's already given. So you would write something about an obtuse angle, and then its measure being greater than 90 degrees. So this is how you would write that. You would write if an angle is obtuse. Then its measure is greater than 90 degrees. The next one says all numbers divisible by 4 are also divisible by 2. So which one happens first? Is being divisible by 2 first, or is being divisible by 4 first? Well, in this sentence, it's the divisible by 4. So that would be your hypothesis, and then this part would be your conclusion. So whenever you write it in an if-then sentence, it's if a number is divisible by 4, then it is also divisible by 2. All right, so in this one it says the states on the East Coast border the Atlantic Ocean. So would you have to say that, because this one is kind of a definition, being on the East Coast means that you border the Atlantic Ocean, at least if you're talking about America, which is where we all live. It's really a definition because it means being on the East Coast. Being on the East Coast means living by the Atlantic Ocean. So it really could go either way, but remember, just like number 4, if it comes first when it can go either way, then you need to just write it in that same order. So it would be like, oops, that needs to go that way, like that. So I want you to try and pause this now and try to write it your own if-then sentence according to this hypothesis and conclusion. So this is what I put. If a state is on the East Coast, then it borders the Atlantic Ocean. All right, so the next one is Valentine's Day is in February. So what comes first, February or Valentine's Day? Try and come up with what the hypothesis and conclusion is and see if you can come up with the correct if-then sentence. All right, hopefully you got it like this. If it is Valentine's Day, then it is February. And the reason is if you flipped it the other way around and you said if it is February, then it is Valentine's Day, that's not true. There are 27 other days, except for leap year, then there's 28 other days in February that are not Valentine's Day. So Valentine's Day has to come first in order for this to be a true statement. So you kind of have to think about that also. The next one says prime numbers only have 2 factors, 1 and itself. So what would come first, the factors of 1 and itself or the fact that it's a prime number? Pause it and try to write it on your own. So you should have gotten if a number is prime, then it only has 2 factors, 1 and itself. All right, so now these are the manipulations of the if-then sentences. An inverse is formed by negating the hypothesis and conclusion. So remember the original was P and then an arrow and then Q. So if you're negating it, it would be not. Yes, that's what that squiggly line means. Not P, then not Q. A converse is formed by switching the hypothesis and conclusion. So the original was P, then Q, and we're going to do Q, then P. Contrapositive is formed by negating and switching. The hypothesis and conclusion. So the original was P then Q. We need to do Q then P and put nots in it. So not Q, then not P. So yes, the little squiggly line means not. Now the way that I remember this is Converse. Most of y'all know what Converse are. They are shoes. It's a brand of shoes. And they go on your feet. And also flip-flops go on your feet. So we are flip-flopping. So I say that this is flip-flop. And then because we add two nots into the inverse, I say not, because you're adding two different knots. And then contrapositive is the longest word, which means you have to do both not, and flip-flop. So because it's so long, it's the one that has both of them. Okay, so here's what these things mean, this flip-flop, not, and flip-flop, not. So you know that this is the hypothesis and this is the conclusion. So whenever we do the inverse, we're literally going to put the word not into the hypothesis and the word not into the conclusion. Now you may need to add another word in order for it to make sense in the English language. But essentially you're putting that word not in there. So if it is Saturday, then if it is not Saturday is what the inverse part would be. If it is not Saturday, then there is no school. Now you have to think about the opposite of that because you want it to say the opposite. So if there, instead of it saying then there is no school, then you would say then there is school. So is this a true statement or not? If it's not Saturday, then there is school. Well, that's not true because of Sunday. Maybe it's a holiday. So this is false. Converse means flip-flop. So what that literally means is you're going to take that pink part and you're going to put it where the yellow is, and you're going to take that yellow part and put it where the pink is. So if there is no school, then it is Saturday. So I literally flip-flop the yellow and pink. The if and the then stay where they are, but I flip-flop the yellow and the pink. So is this true or not? It says if there is no school, then it is Saturday. Well, what about Sunday? What about holidays? So this is false. And then the contrapositive is flip-flop, not. So we're going to put the pink where the yellow is, and we're going to put the yellow where the pink is, and put knots into them. So if there is school, so remember we have to make it change what it says. So if there is school, then it is not Saturday. Then is this true or false? If there is no school, then it's not Saturday. That's true because we do not go to school on Saturday. So this one's true. So here's another example. You have to find your hypothesis and your conclusion. Highlighters definitely help because you can literally see how to flip-flop them or not. So remember, inverse is not. So we need to put knots in there. So it says if the product of two numbers is odd. So we need to say if the product of two numbers is not odd. Then it says both numbers must be odd. So in other words, both numbers must not be odd. You need to put that word in there. So let's see what this says. It says the product of two numbers is not odd. So in other words, they're even. You could also replace this with the word even and it would have been true. So if the product of two numbers is even, then both numbers must not be odd. In other words, must be even. You could have written it either one of those ways. You could have made it say not odd, or you could have made it say even. So if the product of two numbers is even, then both numbers must be even. So think of any two numbers that we multiply together. 2 times 2 is 4. 10 times 10 is 100. Two even numbers multiplied together will give you an even number. So that's true. Oh, that's not true. Okay, the product of any two numbers. They don't have to be two even numbers. The product of two numbers is even. So their answer. Okay, so a product of two numbers, their answer is even. Well, there are ways that we can get even answers without having two even products. Like 3 times 6 is 18, right? So 3 is odd, 6 is even, yet they give us 18. So that is false. And we call that a counterexample, when you can find an example where it is wrong. So just like up here, we said Sunday or even a holiday. That's called a counterexample. Okay, and you always can find a counterexample for anything that's false, because that's what makes it false. Okay, so I'm going to go ahead and keep it with the even for the knots, just because it makes more sense. Converse, we're flip-flopping, so we don't need to make them even. They still got to be odd, but we're going to take the pink and put it where the yellow is, and the yellow and put it where the pink is. So if both numbers must be odd, if two numbers are odd. That didn't make sense when I said it the first time. Then the product of the numbers is odd. Or you could say those numbers. Okay, so it says if two numbers are odd, then the product of those numbers is odd. So think of two odd numbers. 3 times 3 is 9. Another two odd numbers, 3 times 5 is 15. Another two odd numbers, 5 times 9 is 45. So they do all produce odd answers. So this one is true. And you can't do a counterexample if it's true. So now we're going to flip-flop not. So we're going to take this and flip-flop it basically. So if both numbers are even, or if two numbers are even, then they are, wait, where am I? Then the product of them is even, or then their product is even. Okay, so let's think about this one. If two numbers are even, then their product is even. So let's think of any two even numbers. 2 times 2 is 4. That's an even answer. 2 times 4 is 8. That's an even answer. So we're going to say this one is true. Last thing we got to do for notes. Sorry it took so long, but it's a lot of writing and that takes a while. Okay. So if the temperature is 25 degrees Fahrenheit, then it is below freezing. The inverse, if the temperature is not 25 degrees Fahrenheit. Then it is below freezing. Then you would say, then it is not below freezing. So is that true or false? It specifically says if it's not 25 degrees, then it's not freezing. But there are a lot of other freezing temperatures. So it's false. And then your counter example could be anything below 32 degrees that is not 25. So you could say it's 30 degrees because the freezing temperature, in case you didn't know, is 32 degrees. Converse. So we're going to take the pink and put it where the yellow is, take the yellow, put it where the pink is. So if it is below freezing, or if the temperature is below freezing, then it is 25 degrees. So if the temperature is below freezing, then it is 25 degrees Fahrenheit. Again, that would also be false because it could, again, be any temperature lower than 32 degrees that is not 25 degrees. So let's say this one is, I don't know, 20 degrees. Why not? It could have been anything. Contrapositive. We're going to take this one and put knots on the inside. I'm sorry, we're going to take that one and flip it. So if it is not below freezing, then the temperature is not 25 degrees Fahrenheit. Now this one is true. If it's not below freezing, it can't be 25 degrees because freezing is 32. So it would have to be above that. So this is true. And that's the end of our notes.